Okay, so test review 16 through 19. So we have a quadratic, and so basically it's asking you to graph it and then to go through and find all the different transformations for it. So if we're graphing a quadratic, we have to start with the points for a quadratic. And so for the points with a quadratic, we do -2, -1, 0, 1, 2. And then since it's a quadratic, the output for -2 is going to be -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So these are the points that we would do specifically for a quadratic, which is what this is because it's a squared. So those are the points we would use to graph this one. So we would take the points, and then to do the transformations, we have a reflection over X and a vertical stretch of 2. So to do the first transformations of reflect over X and vertical stretch of 2, we would take the Y coordinates and multiply them by -2. So we'd get -2, -8 for the first point, -1, -2 for the second point, 0, 0, +1, -2, and then 2, -8. So to do that first set of transformations, I would just take the Y coordinate and multiply by -2. So multiply by a negative for the reflection, multiply by a 2 for the vertical stretch. Okay. My next transformation that I can see is that the graph has shifted to the right 4. So now I'm going to take each of these points and I'm going to shift them to the right 4. So it is a stretch if it's larger than 1, and you don't worry about the sign. You don't worry about if it's positive or negative. You just worry about the size of the number. So 2 is larger than 1, and so that's what tells you it's a stretch. So the negative only tells you if it's a reflection. It does not tell you if it's a stretch or compression. So the fact that it has a 2 there tells you it's a stretch. The fact that it has a negative only tells you if it's a reflection. It doesn't tell you anything else. So we're going to shift it to the right 4. On the test, so you would only do this on the test necessarily if the test had this as calculator inactive. If it was calculator active, you wouldn't necessarily have to do this. So it's good to know how to do this just in case I make this part of a calculator inactive test. And they're fair game to be either. So if we were doing a calculator active test, then you wouldn't have to do this. You could not show this work and just go straight to the table, find the points, and graph them. So taking the points, shifting them all to the right 4, -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6. So that was doing add 4. To shift to the right 4. And then our last transformation is up 3, which we're going to do by taking the Y coordinate and adding 3. So -8 plus 3 is -5, -2 plus 3 is 1, 0 plus 3 is 3, -2 plus 3 is 1, -8 plus 3 is -5. So 2, -5, 3, 1, 5, 4, 3, 4, 3, 3, 5, 1, and then 6, negative 5. So there's what our quadratic would look like. Okay. So our vertex is this point right here, but you can also see it from the equation itself. So it's positive 4, positive 3. The domain, you can look just from seeing the left arrow and the right arrow. So this picture goes forever to the left, goes forever to the right. It doesn't miss anything in between. So this is a negative infinity to positive infinity. The range, we're going to go from down to up. So this picture goes down forever. And then as you look at how far it goes up to that vertex. So whenever we do the range, we use the y coordinate. So it goes up to 3 and then it stops at 3. So for the range, I'm going to do negative infinity, 3. And then because 3 is a number that I can put my finger on, I'm going to do a bracket for 3. So parenthesis bracket. For increasing and decreasing, I always draw my little stick figure guy. So the x value here, because increasing and decreasing are always x values, I've got a negative infinity. For the left arrow, he is walking uphill when he starts. And he walks uphill to an x value of 4. And then once he gets to the top of the mountain, right up here, then he starts going downhill. And he does that to the right arrow. So the word increasing is between the two numbers negative infinity and 4. So negative infinity is always going to get a parenthesis because I can't put my finger on that. When I look at the number 4, I wouldn't consider that number to be part of him walking uphill, so I'm going to put a parenthesis there. Decreasing is in between the two numbers 4 and infinity. And so if I look at that, infinity always gets a parenthesis, and then 4 is not part of what I would consider him walking downhill. It's just kind of in between, so I'm going to put a parenthesis there. Max, min. So this point up here is what I would consider a mountaintop, which means it's a maximum, and that is the vertex. It's the 0.43, so I'm going to put the 0.43 for a maximum, and then for a minimum, I'm going to put none because there is no valley on this picture. Intercepts, x-intercepts, and y-intercept. I do not have a calculator on me, so if you guys have a calculator, a graphing calculator, you're going to do your second trace option number 2 to find your x-intercepts, your second trace option number 1 to find your y-intercepts. I can't do that because I don't have one, so I'm going to go ahead and just use Zoom real quick, or not Zoom, I'm going to use Desmos real quick. And if you guys have any questions as we go ahead and send them in the chat because I have answered a couple so far. Okay. Okay, so x-intercepts are 2.775. 0 and 5.2250, and then the y-intercept is 0, negative 29. Okay. All right, let's go back here. Okay, so now we're going to say, is the graph continuous? Can I trace it with my finger without picking my finger up? So I trace the whole thing. Yes. And then for end behavior, we're going to talk about our arrows. So my left arrow goes down, my right arrow goes down. So now I just have to write that in the notation, the math notation. So I'm going to say as x goes to negative infinity, that's me describing my left arrow. So I look at the left arrow, y goes to negative infinity. So left arrow goes down. As x goes to positive infinity, y goes to negative infinity. So this is me saying left arrow goes down, right arrow goes down. So x describes your left and right arrow, y describes the arrow going up and down. Okay, so this kind of is talking about like all the things that you would have to do to answer these questions. So for 18, to be able to do 18, but because it's the points that you're negative 1, 1, 0, 0, 1, 1, 2, 2. Number 17, the one that is a little bit interesting about that for students is that it doesn't have parentheses. So when you look at this one, if this one is throwing you off, it would be 3x plus 0 squared minus 8. That's how it would look if it's throwing you off that you don't see those parentheses there. For number 19, there is a note on this one. You can see at the bottom of the page you have to complete the square to get the quadratic into vertex form, and then you can go through and do the rest of the problem. So if you were to get it started, there is no number on the right side to move over, so your first step would be to take the negative out and say positive x squared plus 4x, and then have that blank there. And then you would go into the part where you have 4 divided by 2 equals 2, 2 squared equals 4. And that's where you'd say, oh, the 4 is the number in the blank. But I don't really have that. I would not have a hint like that on the test, but I probably also wouldn't put a problem like that on the test. I would put a problem like this on the test, but I wouldn't put it in this context, because if a student didn't get it right here, then they couldn't do anything in the problem, and I don't think that's fair. All right, so to the person who initially asked me about these questions, does that clear up your confusion? Perfect. Okay, so I'm going to go down to the next person who wrote me. I'm going to stick for now with the test questions. So I see that we did have some questions on the more with graphing quadratics, and I will hit those questions, but I'm going to look at the test review first. So there's been multiple questions on 35, so I'll look at that one next. When I looked at, somebody looked at my answer key and had asked a question about that, and I found there was I said typo, but it's not a typo, I just wrote the number wrong. I had written 25 on my answer key and it should have been 14. I wrote 14, and then the next step I wrote 25, and I don't know where I got the 25 from. So let's go ahead and do this problem, but I did get a mistake on there. So for this one, we'll go through, yeah, I don't know where the 25 was. We'll go through the steps. So our first step is to see if there's something that we can add or subtract to the other side to start getting closer to the variable being alone, and we can subtract the 3 over. So we get negative 7 times 5n plus 9 is less than or equal to negative 98. That's our first step. And then our second step is to see if we can multiply or divide something over to the other side, and we can. We can divide a negative 7. And so we get 5n plus 9 inside an absolute value. And this is where, because you divided by a negative, you do have to flip your symbol. Which, to be honest, I'm not sure if I did that on the answer key, so I might have made 2 mistakes. Does anyone know if I did that on the answer key? I think I might have missed that. Okay. So negative 98 divided by negative 7 is 14. And then this is where I made my mistakes. So this is a greater, which means that you have one option or the other option. So one option is that you have 5n plus 9 is less than or equal to negative 14. And for some reason I wrote negative 25. And then the other option is 5n plus 9 is greater than or equal to positive 14. I was going to say 25 because I know that's what I did wrong. So it should say less than negative 14 or greater than positive 14. So that's how you do the greater problems. And for some reason on the answer key I did 25. I don't know why. And then from there, the next step on both problems is the same. So we're going to minus 9. So 5n is less than or equal to negative 25, 23. Minus 9. 33? Goodness gracious. Miss Rice can do some math. 33? This is me trying to figure out where that 25 came from. I have no idea. And then divide by 5. So n is less than or equal to negative 33 fifths. And negative 33 fifths would be a nice decimal because fifths are always nice decimals. So if you would rather write the decimal 6.6, it's a negative. Oh, yeah, no, you guys are right. 23, not 33. Thank you. I did my math bad. See what 23 fifths is. 4.6. Okay. Make sure you guys caught that my math was not great here. So negative 14 minus 9 is negative 23. Did everybody have a chance to fix that? Negative 23. Okay. So you can write it like this, or you can say n is less than or equal to negative 4.6, or n is greater than or equal to 1. Either way you write that answer is great. Both of those will be fine. Okay. Now, 24 through 34 was another question we had. 24 through 34 are actually just like what was it? 9 through 20 on the assignment from Thursday. So if you guys remember, we kind of talked about this in class 9 through 20. I said I was going to start putting them on assignments, but they wouldn't be on the test. I just wanted to start introducing them to you. So they are on the test review, but honestly, they're not on the test. So I do need to make you guys a video of these just so that you guys can kind of see how to answer them. So we can talk about a few of them, but I don't want you guys to think they're on the test because they're not. This was me trying to get some practice in because it hadn't really fit into the unit. So when I wrote this unit a while back, this was me going like, okay, let me get some practice in where I can. And the test review day was like the only day that it fit. So if we were to do one of these, let's do, this is a good one. Okay, so we can go ahead and do this one right here. This is on the test review, 27 through 30. So what I'm going to do is just graph this on Desmos. If I had my graphing calculator, I would just graph it on that. But you, when you approach these problems, you would graph them on your graphing calculator so that you can kind of mess with it on the calculator and find out specific details about it. So they do graph it on the paper for you, but it doesn't give you enough information. Oh, don't zoom. Okay, so there is the graph. And they usually ask questions like, where is the function positive? Where is the function negative? Where does the function equal 0? And just a reminder, when it says the function, it's talking about the y coordinate. So where is the y coordinate positive? Where is the y coordinate less than 0 means where is the y coordinate negative? Where are you getting negative outputs? And then this says where does g of x equal 0? It still means the y value. So where does the y value equal 0 just means like what are your x-intercepts? So if we go to Desmos, we can just look at this real quick. Our x-intercepts, y equals 0 at x equals 1.543 and x equals 3.457. And since these are asking the question where, they're saying a y value, something about a y is happening, and they're asking where, you only have to answer the x value. So the first x value is the 1.543. The second x value is the 3.457. Okay, so if you're asking where is the y value negative, the y value is negative in between those two values. Like right in between here, these are where your outputs are negative. So when they say where is the y value negative or where is it less than 0, what they're really asking is where is the graph below the x-axis. That's what they're really asking. So we're going to say it's when x is between 1.543 and 3.457. So it's 1.543 and 3.457. So what we did is we just used that interval notation. We said this is the lower part of the interval, this is the higher part of the interval. And we're not going to use brackets because we're not including where it equals 0. We're just using where it is slightly less than 0. So I'm going to say slightly less than 0, slightly less than 0. Okay, so where is the function positive? Well, the first section where it's positive is right here. So from negative infinity, which is right here, to this value, So negative infinity to 1.543. That's the first answer. And then the other place where the function is positive is going to be over here, which is the 3.457 up to a positive infinity. That's the other section where the outputs are positive. So 3.457 to infinity. And again, we're saying positive outputs, so not an output of 0, but specifically an output that's positive. So when they say where the output's positive, you're going to say anything that's above the x-axis. When it asks a question like how far apart are the zeros, you just subtract them, and you're going to do just bigger minus smaller. So I'm just going to go back to Desmos, and I'm going to subtract them. So 3.457 minus 1.543 is 1.914. Units apart is the answer for that. So there aren't questions like that on this particular test, but there are questions like this all over the EOC from what I noticed. So they're definitely fair game, and they will be on future tests. Okay, so I think that answers the questions that I've seen so far on the test review. Are there any other questions on the test review specifically? And then I'll start answering questions on that more with graphing quadratics assignment. And any questions on what your assignment is today in general, or questions about what is going to be due tomorrow, or what the plan is? Anyone have questions about that, logistics? The challenge problem. Yeah, number 7. Is that what we're talking about? Okay. So if you look at number 7, you can see within that problem that all of the parentheses are the same. X plus 1, X plus 1, X plus 1. And so what that means is that X plus 1 is like a GCF. So you've got a term times something, a term times something, a term times something. So you can take X plus 1 out as a GCF. So we're going to say X plus 1 is the GCF. And then we're going to write the leftovers from each of the 3 terms. So this is the first term, second term, third term. So now if we write our leftovers are x squared plus 3x minus 28. And so then when we write the leftovers from each of the 3 terms, then we can see like, oh, the leftovers make a trinomial of their own. And so then once we have those leftovers written, we can go ahead and factor that trinomial. And that's just a simple trinomial, so we'll look for what multiplies to negative 28 but adds to 3. So that's 7 and negative 4. So then if you were to factor that completely, the first factor is that GCF that we pulled out. And then the second 2 factors are going to be x plus 7, x minus 4. So it's probably like the funkiest GCF problem we've ever seen. And that's the final answer. Any other questions on the test review? We're good on the test review? So, as far as figuring out if something needs to be factored or not, first thing I would do with these types of problems is get it to equal 0. If the numbers are really big, honestly, I go straight to the quadratic formula. That's pretty typical for me personally. Especially if I can't find a GCF, I'll just go straight to the quadratic formula. And sometimes I'll find out at the end of the quadratic formula, like if the answers are nice, I'll be like, oh, I could have done the, like I could have factored that. But usually I'll do this. And I'll use the calculator method. So I'll do like the negative 28 divided by x, and I'll look at the table. And if I don't find something on the table, then it's pretty sure, like if you're looking at the table and you're seeing only decimals, that means you have to use the quadratic formula. So typically, like I'm not going to give you these types of problems on a calculator inactive test. These are always going to be calculator active. If they were calculator inactive, they would be really, really simple numbers and small. So that's the way that I usually figure out if it's going to be a solve by factoring versus a quadratic formula problem, is that I grab my calculator for any number that's very big and I do the calculator trick just to see if I can find them. Because anything that is going to be the quadratic formula, when you look at the table, all the pairs of numbers are going to be decimals because they're not going to be, you're not going to have the ability to find two numbers that multiply to that. So that's usually what I look for, or like the numbers are big or they're cumbersome. Because the thing is, the quadratic formula works every time, even if the problem is factorable. So mostly just be careful to look at your instructions, because on a test, I will typically tell you the method to use. I'll typically say factor this problem or use the quadratic formula on this problem. I don't usually say use whichever one you want. I usually tell you which way to do it. Any other test review questions anybody has? Okay, I did have one question that was on this assignment, the more with graphing quadratics, and I think that what I'm going to do is actually make a video after this is over. After I'm done with the Zoom session, I will make a video where I go over 9 through 20, how you do every single one of those problems. So I'll do that. I'll go look down and see if I can find my graphing calculator in my car, and then make a video on how you do every single one of these problems, and that way you can check it against the answer key, but also check the video if there's any part of it you couldn't figure out. So I will make a video on that whole part of the assignment. So the assignments for today, let me get all... So everything, okay, let me explain, let me get, real quick, let me get all logged in. 1 second. Stop